Now we have different subnet mask. So there are 3 to 4 questions, and here only the subnet mask will be given. And for this subnet mask, we have to find out number of hosts and number of subnet. That is, how many network bits are there, how many host bits are there. Along with this, we have also to tell that if this is of class A addressing, then what will happen? So a network with different parts, which is subnet, and in those subnet we have different people or computing devices. Those are called hosts. So this is a network. The first IP will always be the address of that network. The last one is the broadcast address. So we always, number of host assignment, 2 will be subtracted. So 2 to the power host bit minus 2 will be the total number of hosts. In all the questions, this we are going to do. So we have 255.0.0.0. What does it mean? This is 255. Okay. So how many bits are there? If you start from left, we just have to seek subnet mask. How many ones are there? So there are 8 ones in the first octet. That is 8 bits are there. So this 255 or 8 ones, 1 bit is basically the network address. It will give you the network address. When you will have an IP address, when you AND it with the subnet mask, that will give the actual network. Network bits are computed by ANDing the subnet mask with the IP. How many ones are there? 8 ones are there. So this 8 bit are for the network, they are actually network bits or subnet bits. Total 32 bit address is there, or 32, you can see this subnet mask. 8 is for network. Always IP will be of network plus host. So when you subtract this 8, which is actually the network bit, from 32, it will give you the host bit. If we AND this 255.0.0.0 with any IP, especially I am talking about class A, the first 8 bit will give you the network. 32 minus 8, which is 24, is for the host bit. Okay. So 8 plus 25, this always have to be 32. That is in the case here also. So 24 host bits are there, and with the formula 2 to the power host bit minus 2. So number of hosts per subnet will be 2 to the power 24 minus 2. First and last address we cannot assign to any system. So this is 2 to the power 24 minus 2. Now, if this is a class A, just as imagine this is a class A subnet mask, then what will happen? How many network will be there? See, 8 are the, this is a default subnet mask for class A. 8 bit are already used. So 8 minus 8 is 0. So you just have, for the subnets, how many are remaining? 2 to the power 0. One network, only one single network. So now the subnet mask is having certain number in the second octet also. So now the subnet mask is basically used to find out the network address from IP. It does not find out the host ID. Please remember, host IDs are the byproduct of subnet mask being ANDed with the IP address. ANDing means 1 1 always 1, otherwise always 0. 1 0 0 0 1 0 0 0 0. Alright. So number of hosts per subnet and number of subnets we have to find out. If the subnet mask is this one, we are not being told that what kind of classful addressing we are using. So now let me write it and then you will understand. 255 will be what? 1111 1111. This is the binary representation of 255. How this 240 will be formed? Most of the questions which are coming are based on this only. The 240 you will find out. So this is see. So we have 240. This is the best way to convert it is to make a box of 8 8 parts, that is 8 bit. The first one will be 2 to the power 0, that is it will have the value of 1. 2 to the power 1, 2 to the power 2, 4 2 to the power 3, 8 2 to the power 4, 16 2 to the power 5 is 32, 2 to the power 6 is 64, 2 to the power 7 is 128. Now, how to convert 240 into binary? This 240 will be found by 128 plus 64 plus 32 plus 16. So 8, 4, 12, 12, 2, 14, 14 plus 6 is 20. So 2 carry. Now this is 10, 10 plus 4, 14, 1 carry. So we have 240. This 240, wherever the numbers we have added, just put 1. Others 0. So 1, 1, 1, 1, 0, 0, 0, 0 is the binary configuration. So 1, 1, 1, 1, 0, 0, 0, 0. Then again 0 8 times and 0 8 times. Okay, you know about this. 8 bit, 8 bit, 0, 0, 8 times. Now this is 8 ones. These are 4 ones. 8 plus 4 is 12. So 12 ones, or you can say this 12 is for the network, or these are the subnet ID bits. 32 bits in all. Subtract this 12, you will get 20. 20 is for the host. Okay. So how many hosts per subnet is possible? 2 to the power 20 minus 2. First and last you cannot use. Now, if this particular subnet mask belong to class M, we are imagining now. In subnet, in the class A addressing scheme, the first 8 bit from the left is for network ID. How many extra we are using? 4. That is how many you have borrowed from the host. If this is a class A, then the second octet, third and fourth, they are not used for the network. So the second octet, which is actually for the host, you have borrowed 4 of them. So this 4 is used for the subnetting. How to find this? If this is class A, 8 bits can be used. Okay. In all you are using 12. So how many extra bits you are using for subnet? 4. And this 4 bit will tell you how many subnets will be formed, how many networks will be formed. Okay. So how many networks it will be? 2 to the power 4, that is going to be 16. So how many networks will be there? 2 to the power 16, 2 to the power 4, that is 16. So 16 subnets or 16 network parts. Next one, now we have 3 octets having certain numbers. Previously first, then 2, then 3. So the first 255 is 8 1 bits. Next 255 is 8 1 bits. 254 is what? See, 254, how to add certain numbers of 2 to the power to get 254. Again the same thing we'll do. We'll make a box. We know the weight or value of each box, and we'll see these values, how many of these values will add to 254. And all these values, the places will be kept 1, the places will be assigned 1, others will be 0. So 1 1 1 1 1 1 1, all of these, only 1 we have left, because 2 plus 4 plus 6, 8 plus 16 plus 32 plus 64 plus 128 will give you 254. If you add them, you will get 254. Only 1 is remaining, because you know 255 is all ones. So if you just keep 1 away, that is, if you don't include the last one, all ones except this last one will give you 254. So the binary conversion is quite easy. So we have 7 ones and 1 zeros. First 55, 8 1 bits. 255, 8 1 bits. 254, 7 1 bits and a 0. And then we have 8 zeros for last 0. So 8 plus 8 plus 7. How many ones do you have to compute? How many ones are there? So 8 plus 8, 16. 16 plus 7 is 23. So number of ones are 23. In subnet mask, the number of ones will tell you how many network bits are there. So network bits are 23. Okay, and what will be the host? 32 in total. Just subtract these 23, you'll get a 9. So number of host IDs is 9 and number of hosts is 2 to the power 9 minus 2. Now this is a borrowed, this 7 you have borrowed from the third octet. But if this is a class A, just imagine that if this is class A means first 8 bits from the left of first octet is always network. B, C, D means the second, third, fourth. These are for host. 255 is fixed. Total is 23. If it is class 8 you have to subtract because only 15, this 15 you have borrowed from the host bit. If this is class B, 255 will be network, then you have host and host. If this subnet mask is of class B, what we have to do? See, it will not be 15 then. It has to be 23 minus 16 because the first 2 octet will tell you the network address in class B. You have to subtract 16 then. And if it is class C, you have to subtract how many? Well, this will not correspond to that example because this is not 255 in the third octet. But if we assume it to be class A, first octet is for network, so you have to subtract that, and it will be 15. 2 to the power 15 will be number of subnets. If this is class A. Now consider this subnet mask. So we have all the octets filled. 3 are with ones, 240 the last one. So class A network host, class B network host, class C network host. So this is the formation for class A, B and C if this is the subnet mask. So if you are taking class C, you know that the first 3 will be for the network. The last one will be from host. Default subnet mask is for class C is 255, 0. So we are not being told that which type of subnet mask it is. We have to find out the subnets and the host per subnet. So we have 8 1 bits, 8 1 bits, 8 1 bits, and 240 we have just seen 1 2 3 4, then 4 zeros. So 4 ones and 4 zeros. If you start with the left. So first 3 octets ones, last octet 4 ones and 4 zeros. So how many ones are there? 24, first, second, third octet, and 4 in the fourth octet. So 24 plus 4 is 28. So we have 28 as the network ID or subnet ID. Total is 32. How many are remaining? 32 minus 28. So you can also say that this 4 we have borrowed from the host, and that borrowing will give you subnets. So 2 to the power 4 minus 2, that these number of hosts per subnet you can assign. If this is class A, let us assume that this is class A. In class A, the first will be always network. Okay, so you don't have to worry about it. You just subtract this from number of ones. How many number of ones are there? 28. Subtract 8, you get 20. That 20 will be used for the subnets. That is, if it would have been class B. Then the first 8 this 1 bits, second 8 1 bits, this has to be subtracted. 28 minus 16. And if class C, 28 minus 24 has to be done. 8 8 8. Okay. So 2 to the power 12 in the class B case, 2 to the power 4 in the class C case.